Alright, so let's have a look. We already did the departure briefing. Let's go.
Right face.
Okay. Goed is. Weg ermee. Okay. Pushback and startup clearance. Let's pretend that we have startup clearance. Taxi does not work, unfortunately. Windows and doors are closed. Cockpit door. Close the cockpit door. Actually, let's close the exit first. Oh, it is closed. Perfect. Ja, dat is goed met jou. Cockpit door is closed and locked. Perfect. Windows and doors are closed, beacon is on.
Okay, so now we are ready for push and start. So all the checklists have been completed. We've done the one check completed. iPad push checked and all that performance. So we're ready to go. So let's go for push and start. So it will be Airbus 123.
Okay.
Request push and start from start Charlie 12.
Says Beeper 90865, we are ready for push and start. Beeper 90865, push and start approved, face west. Push and start approved, face west, Beeper 90865.
Hello, Captain. We are ready for pushback.
Hello, so are we. Normal operation, standard callouts, dat is de F-com. Nee, is wel de FCTM. Oh nee, dat staat een F-com, dat staat wel een F-com. Even kijken. Waar hebben we die? Normal procedures. Dit is hem niet. Hij staat hier. Dat zijn de checklisten, maar die zijn outdated. Standard callouts. Ground for cockpit, clear for pushback. Cockpit from ground, release park. Okay.
Departure check completed. Bypass pin inserted.
Niet blij met me.
Locking gear.
En dus even kijken voor engine starts. pauzeren. FCTM, wat zegt de FCTM? Introduction to engine start. Engines usually start using the automatic starting function. The full authority digital engine control, or the FADEC systems, control this engine automatic starting function and takes appropriate action if engine parameters are exceeded. This function extends significantly the duration of the engine life. The thrust levers must be confirmed at idle before engine start. If the thrust levers are not at idle, the thrust increases above idle after engine starting can result in a hazardous situation. They're in idle. However, an engine start fault ECAM alert triggers to indicate that the flight crew must set the thrust levers to idle. Perfect. Introduction complete. Automatic starting sequence. The APU bleed enables to start the two engines simultaneously. The engines are started in sequence, engine 1 and 2, and then engine 3 and 4 simultaneously. When engine start selector is set to start, the FADECs are electrically supplied. When there is sufficient bleed pressure, the captain begins the start sequence by setting the engine master levers 1 and 2 to on. A white attention getting box identifies the starting engine parameters. The flight crew should monitor the start sequence by monitoring the following. Start valve opens, N2 increases, ignition A or B, fuel flow, EGT, N1, oil pressure increases, start valve closes and ignition indication off. After reaching the peak EGT or when a veil appears on the engine warning display, the captain can start engines 3 and 4. For more information refer to FCOM automatic engine starts. Let's have a look. Staat hier zeker toch? Ja. Okay. An average idle engine parameter is good to know. As soon as the engine start is complete, the flight crew should check the stabilized parameters at ISA sea level. Thrust should be 3.5%, about 3.5%, and 1 should be around 20%, and 2 should be around 66%, EGT should be around 430 degrees Celsius, and fuel flow should be around 1280 pounds per hour, which is, let's have a look, 1280 pounds to kilograms, 580 kilograms per hour. Flight crew should check the relative engine vibration level. In case of an engine start malfunction, if the start is not successful, the flight crew must apply the ECAM actions as usually done and avoid instinctively selecting the engine master switch to off, so we should not do that. This would interrupt the FADEC protective actions, for example cranking after a hot start. After an aborted engine start, the flight crew must consider dry cranking the engine before performing another engine start. See FCOM limitations engines. Let's have a look. Let's see. After an aborted engine start, the flight crew must consider dry cranking the engine. How would we do that? Why is it saying G-load? Yeah, that's for cranking. Let's have a look. Let's have a look at the engine limits, let's go over that. Test setting and EGT limits. During takeoff and go around and all your engines are operative, the time limit for being at the thrust setting / EGT limit is 5 minutes and EGT limit is 1002 degrees Celsius. For one engine and up, time limit is 10 minutes. Max continuous thrust is not time limited, EGT limit is 970 degrees Celsius. For starting on ground, the EGT limit is 745 degrees Celsius and in flight 865 degrees Celsius. And no time limits for both. Let's see, oil limits. Maximum continuous temperature is 177 degrees during 5 seconds or 163 degrees Celsius during 20 minutes. Minimum starting temperature is minus 40 degrees Celsius. And minimum temperature prior to takeoff is 50 degrees Celsius. Minimum oil quantity. We know that's at least 10 quarts and 0.4 quarts, I believe, per flight hour, on top of 6 quarts. And then it's the higher of the two. Minimum oil pressure is 25 psi. Shaft speeds, N1 max is 111% and N2 max is 118.7%. Let's have a look. Starter limits. 3 periods of 5 minutes, 5 minute continuous starter use are possible. Okay. The FADEC monitors the starter on time. When the starter on time exceeds 5 minutes continuous operation, the engine start fault starter time exceeded ECAM alert triggers. The starter on time resets when the flight crew sets to off the engine master lever. The starter on time begins when the flight crew sets to on the engine master lever and stops when the starter disengages, for example when N2 is 58.4%. After a long period of use, a starter cooldown period is required, approximately 2 minute cooldown for each minute of starter time. Let me read that again because my brain couldn't identify that. After a long period of use, a starter cooldown period is, approximately 2 minutes cooldown for each minute of starter time. So for 1 minute, it requires 2 minutes, 2 times that. When the starter accumulates 15 minutes of use, the starter must cool down for 30 minutes before a new engine start is attempted. But why would you engage the starter for that long? If the M2 is above 25%, no running engagement of the starter is possible. Note, high tailwinds, for example higher than 25 knots, may have an adverse effect on start. It may be necessary to reposition the airplane into the wind. Limits for reverse thrust. Selection of reverse thrust is prohibited in flight. Duh. Backing the aircraft with reverse thrust not permitted, of course. Maximum reverse should not be used below 70 knots when the indication starts to fluctuate. Either reverse is allowed down to aircraft stop. Reduced thrust takeoff. Takeoff at a reduced thrust is allowed only if the airplane meets all performance requirements at the takeoff weight with the operating engines at the thrust available for the flex temperature. Takeoff at reduced thrust is allowed with any inoperative item affecting the performance only if the associated performance shortfall has been applied to meet the above requirements. Note: allowed inoperative items may be identified through dispatch with inoperative item chapter of the AFM or the MMEL. Takeoff at reduced thrust is not allowed on contaminated runways. The flex temperature must not be higher than ISA plus 60 degrees, so in that case this would be 75 degrees Celsius. And lower than the flat rating temperature, the actual OAT. Duh. Let's see. Takeoff at reduced thrust is not allowed unless the operator establishes a means to verify the availability of takeoff thrust to ensure that the engine deterioration does not exceed authorized limits. Alright, so that's for reduced thrust takeoff and a derated takeoff. I I believe we do not have derate. We only can do flex. Selection of tow gutters not permitted when a derated takeoff is performed except when requesting and any abnormal on which machine is used reduced thrust takeoff of flexible. It's not permitted in conjunction with a derated takeoff. Yeah, we don't have a derated takeoff. Soft go around. I believe the aircraft does have soft go around the fly-by-wire one. The use of GA soft mode, soft go around function is prohibited on airport with misapproach gradients greater than 8%. And that's all limitations for engines. In case for manual engine start, the flight crew should only perform a manual start if the EGT margins are low. What margins? For the EGT. Residual EGT is high, and right crank is performed. I'm sorry, I'm still getting used to the controls. This is the manual engine start. It has alternate mode. What does alternate mode do? Aircraft systems. Let's see, engines, where's engines? Ignition and starting. Manual starting. Hey. Start system alternate mode. Not sure if I will find that. Nope. Apparently not. Well. Alright, let's see. Let's see if it will find the alternate mode. Well, I can't find it. Let's continue. For manual engine start, let's see. We just, yeah, we checked that. Manual engine start procedures, read and do procedure, refer to supplementary procedures before starting a manual engine. VDEC has limited control over the manual start process. It ensures that the engine start valve goes at 58% into there's engine parameters. Okay. Generates and associated warning when necessary. It is recommended that the flight crew use the stopwatch to ensure that starter engagement time remains within limits. The EGT increases within 20 seconds. Tailpipe fire. An engine tailpipe fire may occur at engine start and may be the result of either excess fuel in the combustion chamber or an oil leak in the low pressure turbine. Tailpipe fire is an internal fire within the engine. No critical areas are affected. The right way to deal with an engine tailpipe fire is to ventilate the fire. This procedure is not referred as memo items. The tailpipe fire checklist is available in the abnormal procedure menu. Let's see. Tailpipe fire. It's still work in progress. Even kijken. Tailpipe fire, checklist is FT ground, crew reports tailpipe fire, the flight crew must perform the following actions. Shut down the engine, master switch to off. Do not press the engine fire push button. Crank the engine by using either the bleed opposite the engine. Crank the engine by using... Start to crank the set now, start on. Do not use the engine fire push button. This would stop power to the Felix and would stop the motor in sequence. The fire extinguisher must not be used and it will not extinguish an internal fire. As a first priority, the engine must be ventilated. If the ground crew reports a tailpipe fire and bleed air is not readily available, a ground crew fire extinguisher can be used as a last resort. Chemical or dry chemical powder causes serious corrosive damage to the engine. So you have an engine warm up period of the engine start in order to avoid thermal shock to the engine. The engine should be operated at idle or near idle for a minimum of 3 minutes. 5 minutes recommended prior to takeoff before sending the thruster with a high power. The warning can include any taxi time at idle. So at least 3 minutes, 5 minutes recommended. Even kijken, nou gaan we verder met start. Lights are on, those start idle, pushback do it. Engine start, regardless of the thrust levels. The thrust levels are not. Parking brake is not required. Parking brake on the triple pressure indicator. The left and right brake pressure indicator should be about 3,500 psi. Yeah, that's correct. If pushback is required for additional information on the associated callouts, refer to summary for each flight phase. Let's have a look. Let's see, for the event when ready for pushback and pushback clearance received from ATC. I will say ground from cockpit, cleared for pushback, pushback approved, yeah we know. Parking brakes released, ready start engines, starting engines, ready start engines, cleared start engines, starting engines 1 and 2 and 3 and 4. Pushback completed, set parking brake is set when ready to disconnect after engine sensors. Engines started and parameters are stable. It's clear to disconnect. Standby hand signal left to right. Perfect. And after engine start, flight control check. Full up, full down, neutral, full left, full right, neutral, full rudder, full left, full right, neutral. And then we have to start checklist. Do not use the brakes during pushback unless required due to an emergency. Even wachten. Alright. Even kijken. parking brake on, nose fuel steering disconnect memo is displayed. In case of a pushback, ground crew should set the toe pin to the towing position of the steering nose gear panel. In case this position, okay, perfect. Question: if the ECAM does not display this memo, but the ground crew confirms that the toe pin is in the toe, flight crew should not perform the pushback in order to avoid possible damage to the nose gear upon green hydraulic pressurization to dispatch. Acts in such case, refer to the MEL. When the pushback is complete, set on. This is so weird. French people cannot write in plain English. Set to on the parking brake handle. It should be set the parking brake handle to on, right? Set to on the parking brake handle is not correct English, right? Maybe it's me, I don't know. And ask the ground crew for tow bar disconnection, then before start checklist. Okay.
There's a clear to push start facing north from Charlie 12. We'll read that back. And then the next acronym I like to use is LDVPST. So that stands for lights, so we'll put the beacon on. D is doors.
Hey.
So
Hello. Shit. Hold on. Yeah, that's fine. Maybe with develop mode. Here we go. Resume. Thank you.
we'll check a few things here. Firstly, on the door page, all the slides are armed. So that's 5 on the main left, 3 on the upper left, 3 on the upper right, 5 on the main right. Checking that the cockpit door is shut, and also finally I also like to check that the window is not showing any red clip here, and the green shows that the window is locked. Let's close that for now. V means video. So here I would set up the ONS, which I have already. So to get the ONS, you just need to reduce the NUH selector to zoom, and then you can actually zoom in even more if you turn it to the left more. Also, by pressing the taxi push button, that should bring up a new screen on your where your PFD is, and it will show next up you see have a camera on the tail of the plane and a camera on the belly of the plane, and this gives you a nice external view. I like to use it for pushback as well. You can use it just for taxiing if you like, but I like to use it for pushback. It just enhances your situational awareness. It's a really fantastic tool by Airbus because it's so big that if you didn't have it, it does kind of, you'll see it's just a little bit harder to taxi, but this makes life easier when you have that. So unfortunately it's not on the fly-by-wire yet, but I'm sure it will come at some point. So that's B. And then, so LDVP stands for the pressure. Check the body accumulator pressure indication, basically. And then it's in the green band. Key S, you click on serve, and you want to click default settings. that should be a TARA transponder, should be on the appropriate squawk. The weather radar looks like they don't have it yet, as with the towards the terrain system, but that's all you can do for now. So that's what you want to do. And then finally T for thrust levers. I had a little bit of an issue on my thrust levers here. I think that's just my thrust levers. But yeah, you want to make sure that they're idle. Sorry, you want to make sure that the thrust levers are idle and that the reverse is stowed as well. Cool.
But wait, what was the abbreviation?
Push back as well. Cool for commandments, not replicate or there is all our performance. So we're ready to go. So let's go for push and start. So it will be Atlas 1, 2, 3. Press push starts facing north from Charlie 1, 2. We'll read that back. And then the next acronym I like to use is LDV.
What was the first one? PST. Corporation.
Navigation system. 4th of October, okay. It's so PCO, now A is aircraft. So for aircraft, we're going to do a few. Expect to see this, what it will look like. The cockpit. And for example, we'll check in the life vest compartments. There's one bin there that you can remove, have a look down there. And moving back the seats, checking there. And yeah, various different places basically. We'll also check that we have, or we should have, bring up the trees so we can see that they're off out here. It's 25. Okay. Yeah, so that's all good. So that's been checked, and then afterwards we'll turn the batteries back on. And once again on the page, the LTC page, we want to make sure that each battery is below 60 amps and decreasing within 10 seconds. Once you've done that, head over to the A is power. And yeah, I'll use various acronyms during the flight just to make sure I've done everything. So yeah, PCOAP, that's PCOAAP, and the first P is power. So basically there is a laptop here, and we need to make sure that there are 2 green lights in this laptop. If there aren't, then we need to click on serve, create a pressure basically, and then it's in the green band. PS, you click on serve, and you want to click default settings. D is doors, so I want to check a few things here. Firstly, on the door page, cockpit D means video. So here I would set up the ONS, which I have. If you turn it to left more, this is your security is so big. The fly-by-wire yet, but and then so LDVP stands for the pressure check the body accumulator pressure indication, basically, and then it's in the green band. Key S, you click on serve, and you want to click default settings. Then on TCAS above, that should be in TARA.
We'll leave it in normal because we're coming back in immediately.
The weather radar looks like they don't have it yet as with the towards the terrain system, but that's what you can do for now. So that's what you want to do. And then find T for thrust levers. Had a little bit of an issue on my thrust levers here. I think that's just my thrust levers. But yeah, you want to make sure they're idle. Cool, so once we've done that, we can say that, so we can ask for the before start checklist, so back to the checklist button, where it says before start, tick, and it goes as follows: park brake is on, take your speeds and thrust, hit performance, you want to make sure that all your speeds and the flex is in there as well, tune.
Yeah, so we got, let's have a look. This is still the same. Config 1, V1 VR is 141 and V2 is 148. Green dot 189 and flex is 65. Which is correct, we get 190 on the green dot against 189. Flex 1, flex on, anti-ice off. Correct. Being is on, checklist complete.
Yes, check. And they'll check this as well. And that's before start checklist complete. Tick. Okay, that's all done. Beacon's on. We're all good to go. So back to the GSS function. Continue push back, and we want to go nose left.
West.
Let's see how that works.
Release parking brakes, please.
Okay, so let's release my brake.
Park brake release.
Commencing push. All engines are clear. Start at will.
Fantastic.
Thank you, standing engines 1 and 2.
Also, the valve lights is a glitch. I can't seem to get rid of them. And I'll go once to push back. That's it. Cool, that's
Alright, let's see for automatic engine start. For additional training oriented information, refer to FCTM number 80 general. Yeah, we already checked that. For more information on the associated callouts, let's have a look at the callouts. Yeah, no, that's we're clear to start engines. We already checked that, so we went over that.
bring these up.
It's ignition start on the engine start selector. Wait 10 seconds. Clear the door page. Flight crew should wait approximately 10 seconds for
to start our engines as well, so we can clear lights and by ground stuff. So let's go ahead and do that. So start the engines, we go engines, start selector.
Start engines 1 and 2.
We should start. This brings up this page. And now usually we should be waiting for around 30 psi to start the engines.
Okay, minimum is 25.
Seems to be starting 15. So starting 1, and this varies from company to company and aircraft to aircraft. But at my company, we start engines 1, then 2, and then 3 and 4.
Start 1 and 2.
And sometimes we
Please set parking brakes.
just the AP
Brake sets.
Waiting your confirmation for a good engine start.
That's how we do it.
Yeah. Okay, GT.
So this is the start sequence of engine number 1. And we see it's a veil. Good, start number 2.
1 into a veil. Let's have a look at the standard. Ongeveer 3,5, ongeveer 20%. Oké. Perfect.
Cool, so the call is set. Park brake. We'll look outside first, make sure they're not moving, which we're not. Register the park brake.
Waiting your confirmation for a good engine start.
So we'll get that confirmation once we start the engines. So 56% into start valve should close. So that's just offside.
58.4. He's saying 50, or 56, but I remember 58.4. Yeah, 58.4.
So veil. Cool. And now we can start through.
Setting engine 3
Start
4.
3 and 4. Yeah, that reverser 2 is just to get my thrust lever not working. As you see, it does take a while with 4 engines and the way we start them. It's always going to take some time. But we should be monitoring the start sequence, make sure no limits are exceeded.
Super crazy as well. 56% too. Get a good start on number 4 and on number 3. Let's have a look at the fly-by-wire SOP. Engine idle parameters, verify that the international standard atmospheric sea level, which we currently are, with the bleed set off. And the bleeds off. That the turtle's at approximately 3%, we're at 4.2. Exhaust gas temperatures around 455, or 370s are very low, but that's good. Then one parameter is approximately 20% in 2, we're at 18.6, so sure. 2 is at approximately 66. 63.7, a little low. And fuel flows around 635 kilograms per hour. That's a bit higher. Interesting. Tolerance of excess for the N2 vibrations are 5 units over the limit. Or 1.9. However, this is only tolerated on a short amount of time and only during the start sequence. This is due to thermal stabilization of the engine. Full authority direct. The FADEC will automatically crank the engine for 20 seconds when the N2 level reaches 20%. Okay.
Cool, and that is 4 good engine starts. So after the 4 engines have been started, the flow is as follows. It starts at a stop. If you start.
Oh, wacht hier. Hier. Ground run up, danger areas, minimum idle thrust. Okay. That's fine. Look outside. I mean, he shouldn't be there. There we go. Oh, this is fine. I have to start for the FCTM and just start selector number 90. I have to start what? Starts like no, saying the norm, saying the engine start select the norm indicates the end of start sequence. If the start engine start selector remains in the ignition start position, this prevents a continuous ignition on the ground. The flight crew should set the engine start select the norm, then the ignition start to activate continuous ignition on the ground. The flight crew should then perform the start actions. Why would we want that? Why would we want continuous ignition? The wheel SD page appears instead of the engine SD page after this, which we have. Note, if the flight crew does not set the engine start selected to norm, the wheel SD page automatically appears instead of engine start of the engine synoptic display 30 seconds after the last engine start. To prevent thermal shock, then you should run it idle on taxi thrust for a minimum of 3 minutes, 5 minutes recommended by the takeoff. What I want to know, it says more here on the wheel synoptic. I'm gonna have a look at that because I want to know if we have more information available to us. I have the wheel system display. Oh, more. The more key on the ECP can be used to display additional landing gear information when pressed. The more data will change from dot dot dot, more grayed out, to more underlined in white. The following additional information is displayed: the brake control and the steer control indications, and the skid indication, the tire pressure, and the wing anchor pressure indicator. Let me see if that works. No, we don't have that modeled. That's odd. So this page isn't fully accurate, I assume. Maybe it is, but maybe I don't know.
The anti-ice we don't require today, but that's what we put on if we needed it.
Let's see, engine anti-ice. All engine anti-ice push button switches start as required. Put on if the engine anti-ice push button switch if icing conditions exist or are anticipated. The definition of icing conditions is when the temperature is 0 degrees or lower and visible and moisture is visible. Let's have one more look at that. Supplementary. Definition. Nice. Icing condition exists when OAT on the ground and for takeoff or T80 in flight is 10. Huh? What? Okay. Outside air temperature on the ground and for takeoff or T80 in flight is 10 degrees or below and visible moisture is in any form present, such as clouds, fog, with visibility of 100 mile or less, rain, snow, sleet, ice crystals, communicating with weather. Icing conditions exist when the OAT on the ground and for takeoff is 10 degrees or below. Okay. Maybe. Oh, hold on. I'm not crazy. I swear. I swear it's different in this other Afghan. Okay. I'm crazy apparently. Operating in icing conditions. Flying icing condition engine anti-ice. Engine anti-ice must be on during all ground and flight operations when icing conditions exist or are anticipated, except during climbing cruise when SAT is below 40 degrees Celsius. Minus 40 degrees Celsius. Engine anti-ice must be on before and during a descent in icing conditions, even if the SAT is below 40 degrees Celsius. Weird. So why? All right, I get it. Weird. Wing anti-ice, the flight crew may use wing anti-ice either to prevent the ice accretion or to remove an ice accumulation from the wing leading edge. Flight crew should turn wing anti-ice on whenever there is an indication that the airframe is icing up. Indication may be an accumulation of ice on a visual ice indicator between the cockpit windshields. Here we go. Or when the anti-ice severe ice detected caution triggers. I don't know if that's simulated. View of caution, flight crew should avoid extended flight in ice conditions for the slots extended in place. Evidence of significant ice equation to take into account. Isolation on restriction. Minimum speed should be green dot and green and VLS counting 1, 2, 3 and 4. If there is evidence of ice accretion on the ice parts of the airframe, for example, one wing anti-ice. Minimum speed should be green dot, okay. Current configuration is config 3. So, standing water, slush, ice or snow is on the taxation runway when the OAT is less than 10 degrees Celsius. Taxiing in ice conditions, if temperature is less than 3 degrees Celsius, and freezing fog conditions, the flight crew must apply the ice shedding procedure. Ice shedding procedure. Refer to procedure, supplementary 7020 ground ice shedding procedure in case of freezing fog. Ground ice shedding. Ground ice shedding procedure in case of freezing fog. Let's have an overview when taxiing in freezing fog condition. If temperature is less than 3 degrees Celsius, ice may accumulate on the engine fans. Ice accumulation and auto taxi time during which the engines are running on ground at or around idle, for example during taxi in freezing fog conditions. Total taxi time is the cumulative time of the taxi and time of the previous flight and the taxi time. Only flight provided the freezing fog or condition persists between taxi and the taxi out. In order to shed the ice, the flight crew must apply the following procedure at least every 30 minutes. Oh, so this is basically a run-up. Taxi in, because it is necessary to determine the remaining taxi out time that is allowed for the next flight. The flight crew must record in the logbook the taxi in time in freezing fog conditions. Taxi out, it is recommended to estimate with the ATC the duration of the taxi out time in order to assess the total taxi time. Taxi in and taxi out, the flight crew must take into account taxi in time, freezing fog, only if the ground crew did not expect. So it will not accumulate when the aircraft is parked and the engines are off, or what? Flight crew must take into account the taxi in time in freezing fog conditions only if the ground crew did not inspect engine ice and or did not manually de-ice the engine in accordance with the AMM. If the ground crew inspected engine icing and or manually de-iced the engine in accordance with the AMM, the flight crew can consider the total taxi time of 30 minutes as available for the taxi time. Additionally, the flight crew must assess if the ground service and the environment permits the application of the procedure especially. So max taxi time is 30 minutes apparently. Additionally, the flight crew must assess if the ground service and the environment permit the application of the procedure, specifically with regards to slippery runway services, jet blast for the SFB ground run-up, snow and ice. In addition, on the edge of the taxiway, airport noise restrictions. The total taxi time is expected to be less than 30 minutes. Apply the following ice shedding procedure of ground service and environment permit within 5 minutes prior to takeoff or when lined up just prior to takeoff. So ATC notified parking brake or brake with pedals on. Thrust lever 60% in one momentarily. That's the same as on the MD-11. That's so funny. Accelerate the engines momentarily for a short run up to 60% in one. Apply the thrust on two symmetrical engines at a time. So 1 and 4 and 2 and 3 for example. Okay, we can do that. Okay. We can move them separately, so that's very handy. Caution, pay particular attention to aircraft movement during this procedure. If during thrust increase the aircraft starts to move, immediately retard the thrust levers to idle. If the aircraft moves, apply the thrust on only one engine at a time. If the total taxi time is expected to be more than 30 minutes, so it's not limited per se to 30 minutes, just this procedure, yeah. Apply the following ice shedding procedure of the ground service and environment permit at least every 30 minutes of taxi time. It's notified parking brake or brake pedals on. Thrust lever 60% and 1 momentarily. Accelerate the engine momentarily. 1 and 4 for example, and 2 and 3. Pay attention to the aircraft movement. Yeah. We'll line up just before takeoff. Oh yeah, so we do it every 30 minutes of total taxi time and do it just before takeoff. If the preceding ice shelling procedure cannot be applied within 30 minutes of total taxi time, for example, ground surface environment does not permit, first the ground crew inspects is icing and if necessarily manually de-ice the aircraft or the engine in accordance with the AMM. Okay. Without freezing silent, Shannon. Okay, let's continue.
We don't need it to know that can come off. Those PS actions for PM. The spoilers are arms, roller trim, sensible trim, flat. So that can come, but that's what we'll put on if we needed it. And APU, we don't need it to know that can come off. Those PS actions for PM. The spoilers are arms, roller trim, sensible trim. Flaps can be set to the position which they are in one.
So flaps, start flaps for takeoff, check the slides of flaps position on the slides of flaps display of the PFD. If taxiing in icing conditions with range, slash or snow, maintain the flaps retracted until the aircraft reaches the holding point of the takeoff runway in order to prevent contamination of the slide flap mechanism. Okay, go flap 1. Extreme is set to 38.5.
Here. However, we can't. So we'll just have to be on the flight
We've got a good engine start.
Cockpit to ground. We have a good engine start. You can disconnect.
Unlocking the nose gear.
And status potential check as well. You can tell.
The FO and the captain cross-checks that there is no status reminder STS on the engine warning display. If STS appears on the engine warning display, press the STS push button on the ECP to display the status page. ECM status is checked. Clear to disconnect.
Tow truck disconnected. Bypass pin removed. Left is clear. Right is clear.
Thank you very much, till next time. Where are they? It's a wing walker. Oh, there she is. She has the pin. It was just in our nose gear. Perfect. Then we will do a flight control check. For up, for down. Yeah.
Well then. Confirm.
Cockpit to ground. We have a good engine start. You can disconnect.
And now, whilst they're walking away and disconnecting everything,
Unlocking gear.
what we're going to do is we're going to do the flight control check.
Okay. So,
flight controls, pilot flag goes first.
full up. Flight control check, full up.
PM, confirm.
Full up. Full down.
Full down.
Full down.
Disconnected.
Check.
Bypass pin removed.
Neutral. Full left.
Full left.
Left is clear. Right is clear.
Full right.
Alright.
Neutral. And then we'll test the rudders. So for the rudder,
Rudder full left.
we want to press the pedal disconnect.
Oh, that's...
Then rudder
Oh,
slowly.
rudder full left.
Rudder full left.
Oh, slowly. Oh, I did it. Rudder full left. Check. Neutral. Rudder full right. Check. Neutral.
Rudder full right. Neutral. Then PM, we check their flight controls.
to test it separately.
Left. Full right. Neutral. Now you've checked that. You'll check that the ground staff have disconnected, that the tow truck is clear, and that they've got a pin as well. We can see that they have done that, and then we can call for the after start checklist. So again, checklist after start. We've got anti-ice.
To the after start checklist. Anti-ice set as required. Off. Pitch trim. Set the takeoff 38.5 DHS. Checklist complete.
It's off, not required. Take that. Try again. So yeah, so anti-ice is off, and that's the off-start check is complete. Take that, complete. Great, and now we are ready for taxi. So we will request that now. So to request taxi, we'll say Airbus 123 ready for taxi, and then they will give us instruction, probably something like all lines of taxi, whiskey 1, whiskey
Like Alpha 1.
Juliet, we will do that. So firstly, confirm that all is clear on the left, so clear on the right. The nose goes to the taxi, and the rubber turn off the camera light comes on as well. Just going to come up a bit here. And
After start procedure and call out, after ECAM status check, announce to the ground crew, clear to disconnect. Okay, so we should do that after the ECAM status check. After check, nose wheel steering disconnect, memo not displayed, that's checked. Flight control check, which we have done. Start checklist is complete, okay, perfect. Taxi clearance, Speedbird 9865 is ready to taxi at the maintenance ramp. Okay, Speedbird 9865, taxi Mike to holding point Alpha 1, runway 27 right. Taxiing to 27 right via Mike, holding point Alpha 1, Speedbird 9865. Super. Shut up! Shut up! That's crazy. Anyway. Taxi clearance obtained. Taxi camera. Yeah, the taxi camera does not work. That's so stupid. That's really sad. Just gonna have a look at the taxi procedure. Direct visual observation out of the cockpit, windows remain the primary means of taxiing. There's a conflict between outside and the OANS. Display the reference must be the outside view. Of course, that's so logical. How stupid can you be? To trust the OANS instead of your outside view. I mean, you always gotta trust your instruments, but you will trust when taxiing, when you can clearly see out the window, unless visibility is like 0, but anyway. Additional training oriented information for the FCTM number 100 airport navigation, sure. Let's have a look. When ready, the taxi crewman should select as required the taxi for the e-taxi. I'm not available. Zoom for, yeah, we have that. onboard airport navigation system. The onboard airport OANS is designed to improve flight crew situational awareness at complex and busy airports in order to enhance safety by helping to prevent dangerous errors such as runway incursions or takeoffs from the wrong runway, enhance the operational efficiency. It is important to emphasize that the OANS is not a guidance system, therefore the flight crew should not use the OANS as a substitute for taxi procedures. Such taxi procedures include looking outside the aircraft and using airport signs and ground markings. The flight crew must confirm the validity of all information displayed on the OANS by visually comparing this information to outside references, of course. The OANS does not provide information about temporary airport taxi restrictions and may not include the most recent buildings and construction sites. Okay. So I guess it goes up the airport pages from the charts, airport charts. The aerodrome charts. And flight, where was I? The ONS design. Therefore, the flight crew must consult NOTAMs before beginning the taxi phase and can update the moving airport map on the ND by using flags and crosses as necessary. And we can add that, right? Hello. What? Twos on the left, let's for example put a flag on twos on the left or cross. Okay, now I get it. Interesting. Let's see, I want the latest taxi charts. The A380. Control boarding point. Okay, so we should board at Mike 1 and Alpha Yankee 1. So Mike 1 is, I believe, over there. During taxi, the captain and first officer can display the OANS on their ND by selecting zoom in either the arc nav or plan mode. The captain may refer to the ND during taxi if necessary, however the captain's primary reference should always be outside of the aircraft. The first officer will assist the captain during taxi as necessary by referring to the ND in order to locate taxiways and runways. When visibility is reduced, the first officer should announce the aircraft's approach to activate runways. The flight crew member should deselect the OANS and both NDs before line up at the latest. For brakes, brake check. When cleared to taxi, the captain should set the parking brake to off. When the aircraft starts to move, the captain should check the efficiency of the normal braking system by gently pressing the brake pedals to ensure that the aircraft slows down. The first officer should also check the triple brake indicator to ensure that the brake pressure drops to 0. This indicates a successful changeover to the normal braking system. Carbon brake wear. Carbon brake wear depends on the number of brake application on brake temperature. It does not depend on the applied pressure or the duration of the braking. The temperature at which maximum brake wear occurs depends on the brake manufacturer. Therefore, the only way to the pilots can minimize brake wear is to reduce the number of brake applications. Okay. Taxi speed and braking, ground speed indication on the taxi video. Display should be used to assess taxi speed or on the MD or on the PFD. On long straight taxiways when with no ATC or other ground traffic constraints, the captain should allow the aircraft to accelerate to 30 knots and should then use one smooth brake application to decelerate to 10 knots. The captain should not ride the brakes. Sharp turn, captain should reduce the taxi speed to 5 to 8 knots prior to initiating the turn. Body wheel steering limits drag during the turn, and consequently the aircraft speed during the turn should not decrease and no thrust readjustment should be required. Okay. Brake temperature. The FCOM limits brake temperature to 300 degrees Celsius before takeoff is started. This limit ensures that any hydraulic fluid that may come into contact with the brake units will not be ignited in the wheel well after gear retraction. Okay, yeah, that's very important. But we won't, of course. We know this from the A320. Braking anomalies. Anomalies. Braking anomalies. Okay. If the acupressure drops below the green band, the flight crew should be aware that the parking brake can quite suddenly become less efficient. This explains the amber range on the hydraulic pressure gauge of the acupressure. If the flight crew encounters any braking problems during taxi, they should call loss of braking and release the brakes, set the anti-skid to off, and then apply pedal braking. Hold on. If the flight crew encounters any braking problems during taxi, they should call loss of braking and release the brakes, set the anti-skid to off, and then apply pedal braking again. Loss of braking. Brakes anti-skid off. Delay braking until no gear touchdown. Sure. These items are not supported by an ECAM procedure and will be considered as memory items. Or memo items as they call it here. Perfect. Anti-skid back on. And parking brake sets. And 3500. Above 3500 views happen. For taxi roll and steering, general, before taxi check that the amber nose fuel steering disconnect ACAM memo is not displayed to ensure that the steering is fully available, which we have. Thrust use little, if any thrust of idle may be necessary to get the aircraft moving, approximately up to 10% THR at heavy weight. Excessive thrust application on engines can result in exhaust blast damage, for example on airport signs. Thrust should be used symmetrically. Once the aircraft begins to move, reduce thrust as necessary. It can be noticed that the use of engine anti-ice slightly increases ground idle thrust. Yeah, that makes sense. The inner engines are located over unconsolidated or unprepared ground during taxi. Avoid high thrust in the inner engines. Engine ingestion of FOD risk increases. If additional thrust is required, the use of the outer engines is preferred. But what? Yeah, but only if the taxiway itself has potentially FOD. Potentially has FOD because it may be like broken or like, I don't know. To learn better, or it has like these like potholes. Are they called potholes? These like holes in the ground. I don't know. To learn rudder pedal use, pedals control nose fuel steering at low speeds for about 6 degrees with full pedal deflection. Therefore, on straight taxiways and on shallow turns, pilots can use the pedals to steer the aircraft, keeping a hand on the tiller. In sharper turns, the pilot must use the tiller. Steering technique. Nose fuel steering is quote-unquote by wire, with no mechanical connection between the tiller and the nose wheel. That's interesting. That's so interesting that a computer is in between that, the actual tiller and the nose wheel steering itself. The relationship between tiller deflection and nose wheel angle is non-linear, and the tiller forces are light. Therefore, the captain should move the tiller smoothly and maintain the tiller's position. Any correction should be small and smooth and maintained for enough time to enable the pilot to assess the outcome. Being overactive on the tiller will cause uncomfortable oscillations. If both pilots act on the tiller or pedals, their inputs are added until the maximum value of steering angle programmed within the BSCU is reached. When the seating position is... Kan ik dat uitzetten? When the seating position is correct, the cutoff angle is about 19 degrees and the visual ground geometry provides an obscured segment of about 68 feet or 21 meters. Sure. In order to monitor taxi, press the taxi push button. Yeah, we don't have cameras. The taxi cams don't work. This combined view of the aircraft allows the taxiing pilot to properly track the aircraft along the taxi. Yeah, okay. Taxi here. If the taxi display is not available or not clear, for example during heavy rain showers while taxiing on a straight line, the taxiing pilot should see the taxiway or runway centerline arriving between the pilot primary flight display and MD. Okay. So are we a little bit to the left or are we exactly on it? Exactly on it. Also in the middle of our seat. So a little bit to the left. Asymmetric thrust from the other engines can be used to initiate a tight turn and to keep the aircraft moving during the turn. Asymmetric thrust from inner engines is not recommended due to fault risk on certain taxiways. Okay. But I would assume, I mean, yeah, those engines are higher up on the wing, on the outer side. However, there's also grass below it, so like, that's so weird. I would assume that taxiways are usually, at least in Europe or the United States or like America or Asia, that on most international well-maintained airports, it would be way more risky to operate the outer engines than the inner engines, because there's usually no FOD on the taxiways, usually, of course. And the possibility of stuff being in the grass that the engine can pick up would be a lot more likely. But okay, I'm just gonna follow the procedures, but that's sure. When exiting a tight turn, the captain should anticipate the steer out. Additionally, the captain should allow the aircraft to roll forward for a short distance to minimize the stress on the main gears. Okay. 180-degree turns for the FCOM standard operating procedures. .180-degree turns. Let's see, the 180-degree turn on 60 meter or 200 feet wide runways. I believe 27 right is a 60 meter runway, isn't it? Oh no, it's 50 meters. The approximate turn width without margin is 55 meters. Or 180 feet, taking into account the maximum nose wheel steering angle. Okay. This 55 meter or 180 feet turn width is based on the below procedure for a U-turn on 60 meter or 200 feet wide runways. using either the ETEX belly camera or external visual reference as a guideline. This procedure is not permitted in the case of BWS fault. What does BWS stand for? Let's see, page 4422. BWS. Oh, body wheel steering. Procedure is not permitted on a contaminated runway. 180-degree turn using the ETEX belly camera. We don't have it. We don't have the belly camera available to us. So, is it not permitted? Or external visual references as a guideline? Okay, so sure. 180-degree turn. It only has that procedure, so taxi on the runway centerline. During the maneuver, maintain a ground speed of 5 knots. Prefer the use of the ETEX camera display to monitor the GPS ground speed. That is more accurate than the IRS ground speed. Oh, okay, so the ETEX camera display has the GPS ground speed. That's interesting. This is IRS. We don't have the GPS page available. So yeah, sucks to be us, I guess. Monitor the approaching runway edge. Turn toward the edge of the runway with a 20 degree intercept angle and maintain a 20-degree angle on the PFD. Check the 20-degree divergence from the runway axis. When the aircraft approaches the runway edge and approximately 3 seconds before starting the turn, thrust on the outer engine opposite the turn side 20% set. An asymmetric thrust increases causes left or right yaw momentum. This requires the flight crew to slightly adjust the tiller in the opposite direction in order to maintain the 20-degree aircraft divergence from the runway axis. In the lower range of thrust, the engines have a high level of inertia. The 20% thrust preset enables a rapid engine thrust adjustment and good speed control before the turn. On the wet runways, less thrust may be required. Speed, maintain 5 knots. If the aircraft speed goes above 5 knots, control the speed by smoothly applying the brakes in a symmetrical manner. When the outer end of the nose landing gear is approximately 1.5 meters away from the edge of the runway, full tiller apply and maintain. 1.5 meters is the approximate width of the nose landing gear. What is this measurement to pass? The ETEX reference to begin the turn without delay. Yeah, we don't have that. When the aircraft is stabilized and turned and the tiller and the nose wheel steering are at their maximum steering angle, maximum inside turn pedal braking applies smoothly. Flight crew must use the brake pivot turn technique. In the case of the use of the brake pivot turn technique, if the nose wheel steering angle is more than 20 degrees, the BCS BCS 4424. Brake control system, okay. The BCS released the body landing gear brakes in the rear. Well, hold on, in the case of the use of the brake pivot turn technique, if the nose wheel steering angle is more than 20 degrees, the BCS released the body landing gear brakes in the rear wheel and the rear wheel of the wing landing gear brakes. Must an outer engine adjust to maintain 5 knots. If 5 knots is exceeded with full tiller applied, there is a risk that the nose wheel tires skid on the runway. If the aircraft decelerates below 5 knots or stops during the maneuver, gently increase the thrust on the outer engine. Adjust the thrust lever setting according to the aircraft behavior. If the aircraft is at maximum takeoff weight, the flight crew can adjust by around 25% the needed thrust according to external conditions. think of wind or runway condition. For red, runways less thrust may be required. When the turn is completed, to return to the runway centerline, brake pedal release, thrust and outer engine idle set, and tiller smoothly release. Well, I'll be damned. There's also a procedure for just using external visual references. Okay. Okay. I'm gonna pause the sim for a minute because the fuel is running back. 180-degree turn using external visual references. Note, this procedure does not require the use of the E-tags. However, if E-tags is available, this is recommendable, but yeah, sure. Touch on the runway center line during the maneuver. Maintain a ground speed of 5 knots. Monitor the approaching runway edge. Turn toward the edge of the runway with a 20-degree intercept angle and maintain a 20-degree angle. So that's, for example, on runway 27 at the end, turning around at 09er, we will approach the runway edge at track 250 degrees. When the aircraft approaches the runway edge and approximately 3 seconds before starting the turn, there's an outer engine opposite the turn side, 20% set. And note, an asymmetric thrust increases across. Yeah, we know this. In the lower range of thrust, engines apply high inertia, level of high inertia. Note, on wet runways, less thrust may be required. Speed maintain 5 knots. Use the following visual references to determine the position at which to begin the turn in comparison to the runway edge. For a 180-degree turn to the right. Let's see, and here it becomes tricky because I'm a single pilot. For a 180-degree turn to the right, captain. The captain's view of the runway edge corresponds to a diagonal line that is in the pilot's field of view and that passes through the captain glare shield at the bottom of the hump. Then through the captain PFD all the way to the right lower corner of the OIT. So yeah. So like this. Yeah. The FO's view of the runway edge corresponds to a diagonal line that is in the pilot's field of view and it passes through the FO PFD to the upper right corner of the glare shield. 180 turn right. Okay. Oh, I get it. Yeah. For a 180-degree turn to the left for the captain, which I am. The captain's view of the runway edge corresponds to a diagonal line that is in the pilot's field of view and that passes through the captain's primary flight display to the upper left corner of the glare shield. Hold on. I'm trying to imagine this. So the runway's over here and so when the runway edge is about here around the loudspeaker, just to the right of it, in between here and the separation. When the runway edge reaches the reference line, full tiller apply and maintain. If when the aircraft is stabilized in the turn, and the tiller and the nose wheel steering are at their maximum steering angle, maximum inside turn, pedal braking applies smoothly. Flight crew must use the brake pivot turn technique. Note, in the case of the use of the brake pivot turn technique, if the nose wheel steering angle is more than 20 degrees, the BCS release the body landing gear brakes and the rear wheel of the wing landing gear brakes. Okay, good to know. Thrust on outer engine adjust to maintain 5 knots. If 5 knots is exceeded with full tiller applied, there's a risk that the nose wheel tires skid on the runway. If the aircraft decelerates below, yeah, we know these. When the turn is completed and to return to the runway centerline, brake pedal release, thrust and outer engine idle set, and tiller smoothly release. Let's go over this once again for a 180-degree right turn. 20-degree angle to the edge. Runway edge detected using visual cues reference full right tiller. So for a left runway it crosses, it's when it crosses over here. For a right runway it's when it crosses over here. Max right pedal braking, or max pedal braking on the other side. Modulate engine 1 thrust to maintain, or modulate engine 1 or 4 thrust depending on the turn to maintain ground speed of 5 knots. Once the turn is completed by 270 degrees, release the brakes, engine 1 idle, and release the tiller once coming back to the center line. Okay, that's all good to know. Let's go over visual ground geometry. Now that we're on the topic of taxiing, let's reset the time, by the way. Visual ground geometry, pilot eye level 7.2 meters above the ground. We can see forward and to the horizon, and then 19.23 degrees below that, which is 20.61 meters that we cannot see in front of us. And then the distance from us to the nose wheel steering to the back is 2.1 meters back. Turn on turning path. On the runways with a width of less than 200 feet or 60 meters, it is not possible to perform a U-turn. For U-turns on a 200 feet wide runway, refer to procedures, normal, standard operating procedures. 180 degree. Yeah, we just checked that. If a runway does not have a taxiway to access the runway threshold or to exit at the end of the runway, or if the runway, if the taxiway is not usable, the runway may have a turn path. Here we go. The type of turn path, this will be the most used procedure. The type of turn path used as a reference in this procedure is a technical. Hold on. Type of turn path used as a reference in this procedure is a technical instruction on civil airports ITAC turn path that was defined for 747s. In case of what is it again? A brake. BCS is brake control system, and BWS is brake and wear system. Hold on. 4418. Body wheel steering, of course. Why is it not doing what I want? In the case of a body wheel steering fault, the flight crew must slightly increase thrust settings. It is not recommended to turn on the turn path if the runway is wet. This procedure is not permitted on a contaminated runway. Let's see, I take turn path. Oh, these dimensions. Holy shit. That's a lot. Procedure. Well, let's just... That's a lot of dimensions. Procedure. Taxi on the runway center line. Use the ETEX belly command to maneuver. We don't have the ETEX camera. However, it is possible to... Oh, never mind. It is possible to perform the maneuver without a belly camera. When the aircraft approaches... Oops. Hold on. Can I put it back? Here we go. When the aircraft approaches the turn path, reduce and maintain the speed to 5 knots. Use the GPS... Yeah, we do not have the GPS ground speed. At a very low speed, GPS ground speed is more... Yeah, sure. When the aircraft is in a straight line, aligned with a yellow turn path line. Is in a straight line, aligned with a yellow turn path line, 30-degree divergence having from the runway axis. Just an outer engine opposite the turn side, 10% set. I'm imagining one to the left. An asymmetric thrust increase causes left yaw momentum. Alright. We get it. This requires the flight crew to slightly adjust the tiller in the opposite direction in order to maintain the aircraft alignment. Sure. In the lower range of thrust, the engines have a high level of inertia. A 10% thrust preset enables rapid engine thrust adjustments and good speed control before the turn. When the aircraft is at the maximum takeoff weight, a 15% thrust can be preset. Note, on wet runways less thrust may be required. Speed, maintain 5 knots. If the aircraft speed is more than 5 knots, control the speed by smoothly applying the brakes in a symmetrical manner. The flight crew begins the turn using the arrows painted at the outside of the turn. Arrows painted outside? What? Flight crew must start the turn when a virtual line indication of direction of the arrow crosses the shoulder of the pilot flying. Yeah, because the nose wheel is slightly behind us. So I assume at Manchester they have a turn path like that. However, I know for sure that the polar band doesn't have that. But the polar band is 60 meters, so you can make a U-turn. Let's have a look. Oh, they have oh. Sure. The flight crew begins the turn using the arrows painted at the outside of the high-tech turn path. The flight crew must start the turn when the virtual line indication by the direction. Oh yeah, when the pilot flying reaches the arrow. If there is no arrow to start the turn on the turn path, the flight crew can use the belly camera to start the turn on the turn side. We don't have the ETEX camera, I'm sorry. Full tiller, apply and maintain. Flight crew can use the differential brake to shoulder the turn if necessary. There's an outer engine, maintain 5 knots, so adjust for that. Speed, maintain 5 knots. If 5 knots is exceeded with full tiller applied. There's a risk that the nose wheel skids, we know that. Through this when the turn is complete, brake pedal released, confirmed, thrust and outer engine idle set, and tiller smoothly released. Perfect, alright. For additional training oriented information for the FCTM. This takes so long. to the brakes. We already read that. And rudder pedal use we also... Hold on. Yeah, we checked that. Okay, let's just go for now. Lights taxi, runway turn off, that's fine, it's on. Okay. Let's have a look at the thrust levers. Little of any power, but oh, we need to check one more thing. Takeoff briefing confirmation. Takeoff briefing should usually be a brief confirmation of the full takeoff briefing made at the parking bay and should include any changes that may have occurred, for example changes shit, changing runway conditions, etc. No changes, briefing is still complete. We are departing in an A380 today. It's crazy. From Heathrow, runway 27 right with standard conditions, wind 0 at 0, 15 degrees Celsius temperature and 1013 hectopascal. Taking off calculated is for 350 tons and actual gross weight is currently 346.1 ton. Flag 65, flap 1 backs on, anti-ice off, E1 141, VR 141 and V2 148. Initial climb is 6000 in blue and 141 is the V1 speed in blue and 148 is the V2 speed in magenta. Takeoff briefing is complete. For thrust levers as required, little of any power but out of thrust can be necessary to move the aircraft. Oh yeah, we already checked that. Okay, let's just start.
Goes to taxi and the runway turn off and camera light comes on as well. Just move along a bit here. And release the parking brake.
Parking brake released.
And thrust wise. So previously it's been quite
Do a brake check.
thrust to get going.
Brakes are 0.
That's the case here as well. Now you're not supposed to exceed 15% on the 380. But I am just going to do this here because otherwise I am supposed to exceed 15% on the 380. But I am just going to do this here because otherwise we're never going to move. But in the real world, you wouldn't, you're not supposed to exceed 50%. I'm going to set 20 just to start going. But don't exceed 15% if you're flying this in the real world. Cool, next check is a brake check, so just check, be pressing the brakes, and we'll call this pressure 0. Pilot monitoring is looking here.
Yeah, because what is the call out exactly? Clear left side, clear right side. Brake check, pressure 0.
Pressure is at 0. Again, I'm going to increase the thrust. This is something that probably needs to fix whether or not. Because this is too much thrust. So go around to the left, slight oversteer, obviously this is such a big plane, so we have to oversteer a little bit.
take it to the... We'll go over this when we hold at mic 1.
So the number is that was 123 Whiskey 4 turn right 12 Juliet, right Sierra, Charles Charlie, which will do.
Well, here's mic 1. Right, holding short of mic 1. Parking brake is set. Let's pretend that we had to change. Let's just go over it. Let's just read it out loud. Take up data computation of multiple Romy selection was used in anticipation of thermal change. Oh, you can do that? Take performance results, go check in the FMS active performance page. In case of ATC cleans or the ticket from a change ticket product data update. Update the FMS in accordance with the new results of the data performance computation, i.e. update the ticket panel of the FMS active FMS flight plan. The flight crew anticipated thermal change in the secondary flight plan. We don't. Yeah, okay, that's checked. In the case ATC claims your ticket runway change, press it, revise your check, carefully confirm that the ATC clearance agrees with the FMS nav modes to be used. Initial climb speed and speed limit, revise your check. Yeah, this is all very straightforward. Heading on. The ATC requires a heading after takeoff, we don't. But in the case we do, in the case for radar vector departure preset heading on the IFS CP, nav disarms. For information refer to DSC to define a heading for preset for takeoff. DSC, what is DSC? I don't think we have that. Roaming track maintenance. FT check selected on. PFD. Yeah, let's check. Take a configuration. Take a briefing. We've already done. Take a briefing confirm. Take a briefing should usually be only a brief confirmation of the entire take a briefing that is done at the gate. Flight crew should address any clearance changes at this time. On the brake, RTO arm. RTO arm light comes on. Brake RTO appears in the FMA, which it did. Yeah. Flight crew can arm the other brake in the RTO mode even if the parking brake is set to on. The RTO mode improves the safety in the case of an aborted takeoff. If the takeoff is aborted, the other brake system applies maximum braking as soon as the thrust levers are set to idle and if the speed is above 72. Takeoff is aborted out by applies maximum as soon as the thrust speed is above 72 knots. Corresponding to the order of ground support exit below 72 knots, the auto brake does not activate because the ground supporters do not automatically extend. Okay, so below 72 knots, we gotta brake manually. HC code, let's have a look at serve. 2000 auto norm. Out, RTG is on. Perfect. Final check, takeoff config, push button is tested and takeoff config is normal. Press the takeoff config push button on the ECP and check that the EWD displays the takeoff config normal memo. Takeoff memo no blue line. Check that the EWD does not display any blue line in the takeoff memo section. Cabin ready, check cabin ready on the EWD or obtain the report from the G-ports and cabin ready for takeoff. we not need to say cabin crew take your seat for takeoff? No, do not. Okay, so apparently we don't need to say that. I'm just gonna cabin crew to seat for takeoff.
In a straight line now. So we don't have to worry about turns. Our workload is nice and low. So what we'll do now is we will do a little just pre-departure briefing. So the first thing I'm going to do is to check the P15 on the E-tax, the external taxi in camera system. I'll just, come off that, check the P15, make sure we've got the speeds and the FMA, and we're close to 4,000 feet. We'll just talk briefly about our clearance and our non-standard engine out SID. And then after that, I'll look at the pilot monitoring to do the taxi flows. So with that, you just arm the RTO like that. Check the squawk is good, which it is. Take off config, and now we're going to take the config on. And from that, I'll ask for the taxi checklist, which is nice. So the taxi checklist goes as follows. Flight controls have been checked.
Oh, right. Flight controls checked. Flap setting, config 1+F checked on both sides. Radar.
So that's it. Flap setting, got config 1+F, and now repairs as well. Radar is on at this point. We'll put the weather radar on. Going should go for terrain. So take that. That's the taxi checks of the day.
Can we also skip that one? I'll just take it off for now. Checklist, taxi checklist complete.
Okay, so obviously we'll make sure that we do not go past this point here. So we just bring it to a stop. Okay, looking outside, not moving. Park brake is set. Cool. So at this point, whilst we've got the whole chill clearance, we no longer need the ONS really. So what I'll do is I will set that to complete.
You know what? Yeah, I'm gonna continue texting to Alpha Yankee 1 as well. And ground, hello, this is Peeper 9865, holding mic 1. And you would say, for example, Peeper 9865, continue taxi mic to holding point Alpha Yankee 1. Taxiing to correction holding point Alpha Yankee 1 for 27 right via mic as Peeper 9865. So, parking brake released, clear left, clear right. Should have done that reversed. Clear left, clear right, and then parking brake released. That's Mike. That's Alpha 1. So I assume that's Alpha Yankee. That this is Alpha Yankee 1. Vehicle crossing ahead. That's fine, we can turn on parking brake as we're not moving. And ground Peeper 9865, we are ready for departure. Peeper 9865 off the tower, 118.505, tower 118.505, bye-bye Peeper 9865. Tower is Peeper 9865, Super is holding short 27 right, Alpha Yankee 1, we are holding position, we are not ready for departure, we will let you know. Okay, it's Peeper 9865, Super hello, okay, roger that, that's fine.
Initially on 20, and we can start thinking about our takeoff. Might be just running through my RTO actions as well, and then we get the clearance Airbus 123, runway 34 via Alpha 908. So we'll read that back. We'll confirm that the bridge area.
Okay, yeah, that's fine. I'm first gonna read through the FCTM. See what we need to do for a normal takeoff, because we're just gonna do a normal takeoff right now. Pardon me. Miscellaneous strobe light. When the strobe lights are set to auto, they come on automatically when the aircraft is airborne. The on position must be used to turn on the lights on the ground for crossing, backtracking, or entering a runway. Packs, if takeoff must be completed without air bleed from the engines for performance reasons, but air conditioning is desired, and AP bleed may be used with the pack set to on. This will maintain the engine performance level and passenger comfort. In the event of an AP auto shutdown during takeoff, engine thrust is frozen until the thrust is manually reduced. The packs revert to engine bleed. The packs revert to engine bleed that causes an increase of EGT in order to maintain thrust. THR. If one pack is failed before takeoff, it is recommended that the flight crew set the failed pack to off. The takeoff can be performed with the other pack on with toggle or flex thrust. The pack being supplied by the on-site bleeds. In this asymmetric bleed configuration, and one takeoff value is limited to the value corresponding to the bleed on configuration. Okay. In case of clearance, change of ATC clears the aircraft to maintain specific heading after takeoff. Turn the AFS control panel heading selector on the FCU. FCU, that's what it was. To disarm nav, the current aircraft heading will be displayed on the AFSCP and ND, and the flight crew can then set the cleared heading. Once airborne and above 30 feet radio altitude, runway track engages. To follow the clearance, on the flight system control panel heading knob should be pulled. Once cleared to resume the seat, a heading adjustment may be necessary to intercept the desired track for nav capture. Okay, that was before takeoff. Okay. Let's read through the normal procedure for the before takeoff for landing clearance obtain. Cabin crew advise. Oh, here we go. Cabin crew advise about 3 minutes US. About 3 minutes US prior to the estimated takeoff time. Captain call takeoff signal. Hey? What? About 3 minutes prior to the estimated takeoff time. Captain call takeoff signal over the PA, I guess. PAC for additional training oriented information referred to FCTM number 110 PACs. Yeah, that's called miscellaneous over here. We need to check that. Max 1 and 2 as required. We are taking off with PACs on. Consider setting the PACs to off or setting the APU bleed push button switch to on. We don't need that. This improves aircraft performance when using toga thrust, and in the case of a flex takeoff this reduces the EGT and therefore reduces the maintenance costs. It is not authorized to use the APU bleed if wing anti-ice is used. Exterior lights set. In order to minimize bird strike hazard during takeoff, set the runway turn off, the camera switch to on, set land on and nose to on. Not yet. E-tax, if the E-tax was used during the taxi, we'll turn it off. Either CP and D range, we can now turn the OANS off. Perfect. Traffic push button is on, we already did that. Before entering the runway approach path, check clear of traffic. Strobe, switch to on. Take a runway, confirm. Well, we can already see 27 right, Alpha 1. Confirm that the lineup is performed on the intended runway. Use for aids are the runway markings, runway lights. Be careful that in low visibility edge lights could be mixed up with the centerline lights. Check the ILS signal if the runway is ILS equipped. The flight crew can press the ILS push button. Yeah, we do have that. The low gauge should be centered after lineup. The runway symbol and the sliding table is stowed. Because the RA, waiting for takeoff checklist. And Towers Beaver 9865, we would like to line up runway 27 right. Okay, it's Beaver 9865 super, line up runway 27 right. Let me know when you're ready for departure. Line up runway 27 right via Alpha 1, and we will let you know when we are ready for departure. It's Beaver 9865 super. Can we, well, takeoff signal. Sure, I guess. I don't know. Backs on, the exterior lights. Do we need the wing lights? We don't. We are in TARA. Okay, brakes released.
And I'll also probably
Clear right. And runway clear.
Okay, let's thrust leaders then. These thrust leaders ready. Cool. We'll increase thrust and we're being cleared to line up points.
you hit.
They'd probably tell the cabin crew and state the seats for departure.
Well, we are not fully lined up. Takes a while.
So 7 knots is more than enough to line up there.
Okay, parking brake set. Alright, stop.
Okay, and then finally we get the call saying Airbus 123 when discount runway 34 rights cleared for takeoff. So good. When discount runway 34 rights cleared for takeoff. So put the lights on, it's good to take off, and then skids when you're ready. Start the chronometer. 25% initially.
25%. Depending on air, engine variant thrust should be set to either 25 or 30%. Let's check the fly-by-wire SOP. It is recommended to first apply 25% of thrust, okay. Standing takeoff, apply the brakes. For rolling takeoff, release the brakes. If the crosswind is at or below 23 knots and there's no tailwind, brakes released. Levers, note engine system display page will replace the wheel system page on the ECAM display for flex or toga. Triggered by flex or toga being set. If the crosswind is above 22 knots and or in case of tailwind, release turns over 50%. Only 25% and no. Okay. I believe the limits were 35 knots on the crosswind and 10 knots or 15 knots on the tailwind, but there's also like that little arc, so yeah. But we'll set 25%. Alright, let's do the before takeoff checklist. Before takeoff checklist, please. Where is it? Oh right, this changed. Lineup checklist. Lineup checklist please. Takeoff runway is 27 right confirmed. And backs 1 and 2 are on. Checklist complete. Lineup checklist complete. Perfect. Did we do that correctly for each additional information on the associated standard callouts? Yeah. For takeoff procedure and callout. During taxi, it says before takeoff checklist, but this is the lineup checklist, please. Lineup checklist. At about 3 minutes prior to the estimated takeoff time. Takeoff signal, notify the cabin crew to prepare for takeoff. Make 4 chimes. Then position the seatbelt signal to signal. Perfect. Check the cabin ready message on the ECAM memo, or at least obtain the cabin report from the purser. We have, we'll pretend that we have it. Do not take off until cabin readiness confirmation is received. Obtain exterior lights. The Exterior lights are set the takeoff runway turn off, land and nose switches to on and takeoff in order to minimize bird strike hazard during takeoff, and set the strobe lights to on before entering the runway. And line-up clearance, yeah, so taxi for line-up takeoff for takeoff clearance. Weather radar would normally be set to on, however weather radar is currently on up, terrain radar is on. Okay. Each pilot checks his or call final clear, runway clear. Prior to taxiing onto the runway, the flight crews will check the runway number and all. Yeah, we did that. No, this doesn't work yet. Okay, let's go over the takeoff procedure. For training oriented information and crosswind technique, refer to FCTM number 120 takeoff roll. We'll have a look at the whole takeoff FCTM page, which is 120 before takeoff. Let's also go over the actually, let's pause the takeoff. No, actually, let's go over the takeoff and the climb setting, and we can pause whenever we'd like. So, FCTM for normal operations takeoff. Thrust setting, the pilot flying should announce takeoff. The pilot flying then applies powers as follows: from idle to 25% thrust by reference to the TLA indicator on the thrust gauge. TLA, I assume that's the blue dot, blue circle. When the engine parameters have stabilized, the flex, MCT or toga detent is appropriate. This procedure ensures that all engines will accelerate similarly. If not properly applied, this may lead to asymmetrical thrust increase and consequently to severe directional control problems. If the thrust levers are not set to the proper takeoff detent, for example flex instead of toga, a message comes up on the ECAM. When the thrust levers are set, the pilot flying asks changes on the FMA. The pilot monitoring must check that the thrust is set by 80 knots and must announce thrust set. For takeoff roll, the captain must keep his hand on the thrust levers when the thrust levers are set to toga or flex notch and until V1. The pilot flying should use the pedals to keep the aircraft straight. The nose wheel steering will be effective until reaching 115 knots, but its authority decreases at a predetermined rate as the ground speed increases and the rudder becomes more effective. To use the tiller is not recommended during takeoff roll because of its high efficiency, which might lead to aircraft overreaction, of course. I'm not going to use the tiller ever during takeoff and landing, unless during line-up and vacating. Crosswind takeoffs, routine use of into the wind aileron is not necessary. Oh, what? Into wind aileron is not necessary. That's interesting. Strong crosswind conditions, small lateral stick input may be used if deemed necessary due to into wind wing reaction, but avoid large deflections resulting in excessive spoiler deployment, which increase the aircraft tendency to turn into the wind. In case of low visibility takeoff, visual cues are primarily meant to track the runway centerline. The PFD yaw bar provides an assistance in case of expected fog patches if ILS is unavailable. Alright, I need to turn this off. Rotation technique. Rotation is conventional. The pilot flying must perform the rotation mainly head up, using outside visual reference until airborne, or at least until visual cues are lost depending on visibility conditions. Pilot flying must then monitor the pitch attitude on the primary flight display. The higher the inertia of the aircraft is, the more it is important to initiate the rotation with a smooth, positive backward side stick input. Avoid aggressive and sharp inputs. The typical engine operating attitude the typical engine operating attitude after liftoff is about 12.5 degrees. If the established pitch rate is not satisfactory, the pilot must make smooth corrections on the stick. He must avoid rapid and large corrections, which cause sharp reaction and pitch from the aircraft. If to increase the rotation rate, a further and late aft side stick input is made. Further and late. Hold on, my brain is fried. If to increase the rotation rate, a further and late aft side stick input is made around the time of liftoff, the possibility of tail strike increases significantly, logically. During rotation, the crew must not chase the flight director's pitch bar, since it does not give any pitch rate order and might lead to overreaction. Once airborne only, the crew must refine the aircraft pitch attitude using the flight directives, which is then representative of the SRS orders. The fly-by-wire control laws change it to normal flight law, or flight normal law, with automatic pitch trim active. A pitch limit indication is provided on the EPFDO takeoff. It is displayed from the power application up to 3 seconds after liftoff. Tail strike avoidance. Oh, this is an introduction. Let me grab something first. Alright, let's continue. Tail strike avoidance. Introduction. Tail strikes can cause extensive structural damage, well no shit. Which can jeopardize the flight and lead to heavy maintenance action, well no shit. They most often occur in such adverse conditions as crosswind, turbulence, wind shear, etc. Yeah. Aircraft geometry, max pitch attitude on ground depending on main gear, oleo position. Fully extended is 13.5, fully compressed is 11.5, so we shouldn't pitch up more than 11.5 degrees. Okay, so we do have to watch out for that. Main factors. Main factors are, for example, an early rotation. Early rotation occurs when rotation is initiated below the scheduled VR. The potential reasons for this are the calculated VR is incorrect for the aircraft weight or flap configuration, or the pilot flying commands rotation below VR due to gusts, wind shear, or an obstacle on the runway. Whatever the cause of the early rotation, the results, correction, whatever the cause of the result will be an increased pitch attitude and liftoff, and consequently reduced tail stroke currents. Well, no shit. Rotation technique. The recommendation given in the rotation technique paragraph should be applied here. A faster... What? What do you mean the recommendation given in the rotation technique paragraph? This is the rotation technique paragraph, isn't it? Fast rotation rate increases the risk of tail strike, but a slow rate increases takeoff distance. The recommended rate is between 2 and 3 degrees per second, which reflects the average rates achieved during flight test. There's also the reference rates for performance calculations, so about 2.5 degrees of pitch. Huh. No, never mind. Configuration. When performance is limiting the takeoff weight. When performance is limiting the takeoff weight, the flight crew uses toga, thrust, and selects the configuration that provides the highest takeoff weight. Sure. When the actual takeoff weight is lower than the permissible one, the flight crew uses flex takeoff, thrust for a given aircraft weight. A variety of flap configurations are possible. Usually, the flight crew selects the configuration that provides the maximum flex temperature. This is done to prolong engine life. The configuration that provides the maximum flex temperature varies with the runway length. Along runways, config 1+F becomes the optimum configuration in terms of flex temperature. However, the flight crew should keep in mind that the tail clearance at liftoff depends on the configuration. The highest flap configuration gives the highest tail strike margin. Takeoff trim setting. The main purpose of the pitch trim setting for takeoff is to provide consistent... Hold on, I don't understand that last sentence. I was planning on just skipping over it, but with the highest, do they mean flap 3 or flap 1? Okay, so flap 3 gives the highest tail strike margin. Takeoff trim setting. The main purpose of the pitch trim setting for takeoff is to provide consistent rotation characteristics. Takeoff pitch trim setting is automatic on ground. Aircraft performs a safe takeoff provided the pitch trim setting is within the green band on the pitch trim display on the primary flight display. However, the pitch trim setting significantly affects the aircraft behavior during rotation. With a forward CG and the pitch trim set to the nose down limit, the pilots will feel aircraft heavy to rotate, and aircraft rotation will be very slow in response to the normal takeoff stick displacement. With an aft CG and the pitch trim set to the nose up limit, the pilot will most probably have to counteract an early auto rotation until VR is reached. In either case, the pilot may have to modify his normal control input to achieve the desired rotation, but should be cautious not to overreact. Crosswind takeoff. It is said in the takeoff roll paragraph that care should be taken to avoid using large deflection, resulting in excessive spoiler deployment. A direct effect of the reduction in lift due to the extension of spoiler. On one wing will be a reduction in clearance and an increased risk of tail strike. OEO inflation, a correct extension of the main landing gear shock absorber, and thus the nominal increase in tail clearance during the rotation relies on the correct inflation of the oleos. An underinflated oleo will delay the start of the bogie rotation and reduce tail clearances. Yeah, I'm just gonna limit myself to 11.5. Action in case of tail strike: if a tail strike occurs at takeoff, flight at altitude requiring a pressurized cabin must be avoided, and the return to the originated airport should be performed for damage assessment. Let's see, flight guidance, general. The autopilot can be engaged 5 seconds after takeoff and above 100 feet radio altitude. Vertical profile, SRS engages when the thrust levers are set to the applicable detent for takeoff and will remain engaged until the acceleration altitude. In SRS mode, the aircraft maintains a speed target equal to V2 plus 10 in normal engine configuration. What does SRS actually stand for? I don't know that. Speed reference system. Good to know. And SRS, the SRS guidance law also includes attitude protection to reduce aircraft nose up effect during takeoff at 14 degrees. Flight path angle protection that ensures a positive climb. Lateral profile: under most circumstances the crew can expect to follow the programmed SID. In this case, NAP is armed on selecting the thrust levers to the applicable detent for takeoff and engages once above 30 feet radio altitude. Thrust reduction altitude. At the thrust reduction altitude, lever climb flashes on the FMA. When hand flying, lower slightly the nose is applicable to anticipate a pitch down flight director order. Bring the thrust levers back to climb, detent, the auto thrust is now active, auto thrust on the FMA changes from blue to white. The flight director pitch down order depends upon the amount of thrust decrease between tow guard flex and climb. If takeoff was performed with packs off, the packs will be selected back to on after thrust reduction because of the potential resulting EGT increase. At acceleration altitude. At the acceleration altitude, the flight director pitch mode changes from SRS to climb or open climb mode. The target speed, displayed as a triangle, jumps either to the managed target speed, for example the speed constraint, speed limit or econ climb speed, or to the pre-selected climb speed entered by the pilot on the perf climb page before takeoff. The short-term managed speed, displayed as a magenta dot, jumps to the lowest VFE -5 knot of the present aircraft configuration and initial climb speed. So let me see. Short term. Flaps extension -5. Yeah, that makes sense. I get it now. During takeoff phase, F and S speeds are the minimum speeds for attracting surfaces at F speed. The aircraft acceleration was hold on. At F speed, with the aircraft accelerating, so a positive speed trend on the airspeed indicator, then we can retract to flap 1. And at S speed, the aircraft accelerating with a positive speed trend on the airspeed indicator, we will retract to 0. Okay. It's a lot. I mean, I get it. But it's a lot. Takeoff at heavy weight. General. If takeoff is carried out at heavy weight, the maneuvering speed F may be close to velocity flap extension copy 2. And S speed is above, hold on, if takeoff is carried out at the maneuvering speed F may be close to flap extension copy 2 and S speed is above flap extension copy 1 plus F. In this case, two protections intervene, the automatic retraction system, which will automatically retract the flaps in config 1 plus F, and the alpha lock function. Oh yeah. Wait, is it incoming? Let me look it up. It is alpha lock. Let's see, automatic retraction system. While in config 1 plus F at IS speed reaches to 12 knots, the ARS is activated, which stands for automatic retraction system. The automatic retraction system automatically retracts the flaps to 0. It will leave the slats extended. The VFE displayed on the VFD changes from VFE config 1 plus F to VFE config 1. As the aircraft accelerates above S speed, the flap lever can be selected to 0. If IS decreases to below to 12, the flaps will not extend back to 1 plus F, so we will have to extend manually in case we have to slow down, which we never will, but just in case. Alright. The alpha/speed lock function. The slats alpha/speed lock function inhibits the slat retraction at high angles of attack and or at very low speed. When flight crew sets the flap lever to 0. Alpha lock pulses in the flaps display on the PFD. The inhibition is removed and the slats retract when both alpha and speed come back to normal values. The triggering of the alpha/speed lock function is a normal situation at high weight. Okay. If the slats alpha/speed lock function is triggered, the flight crew continues the scheduled acceleration to enable later slats retraction. In case of an immediate turn after takeoff, obstacle clearance, noise abatement or departure procedures may require an immediate turn after takeoff. Provided flight director command bars are followed accurately, the flaps and slats may be retracted using the normal procedure as flight director orders provide bank angle limits with respect to speed and configuration. In case of low altitude level off, which also applies to us, if the aircraft is required to level off below the acceleration altitude, oh, that's not for us. Alt star engages and SRS disengages. The lever climb message flashes on the FMA and the target speed goes to the initial climb speed. In this case, the crew should expect a faster than normal acceleration and be prepared to retract the flaps and slats promptly. For noise abatement takeoff, noise abatement procedures will not be conducted in conditions of significant turbulence or wind shear. This is A380 procedure A380 alleviating noise close to the aerodrome. Takeoff thrust V2 plus 10 to 20. The 800 feet initial power reduction at or above 800 feet. Climb at V2 plus 10 to 20 knots. Maintain reduced power. Maintain flaps and slats in the takeoff configuration. At 3000 feet, maintain positive rate of climb, accelerate smoothly to 100 climb speed, retract flaps and slats as schedule. This for alleviating noise close to the aerodrome. Did not have any notes. A380 procedure A380 alleviating noise distant from the aerodrome. Takeoff thrust V2 plus 10 to 20 knots at 800 feet. Not before 800 feet and whilst maintaining a positive rate of climb. Accelerate toward green dot and reduce power with the initiation of the first flap slash slat retraction. When flaps and slats are retracted and whilst maintaining a positive rate of climb, produce power and climb at green dot plus 10 to 20. Then climb up to 3000 feet, transition smoothly to 100 climb speed. Let's go over to the normal procedures, to the normal operations climb operations. Autopilot and flight director climb modes. The autopilot flight director climb modes may be either managed or selected. The managed autopilot flight director mode in climb is climb. Its use is recommended as long as the aircraft is cleared along the flight plan. In case of selected, the selected autopilot and flight director modes in climb are open climb or vertical speed. Open climb is to be used if ATC gives radar vectors. Ja, ik taal about this cruises. Small altitude changes. Climb or open climb will be preferred in vertical speed mode for climb. Even for small altitude changes. Okay, so that's different on this aircraft than on other aircraft. Indeed, in the small altitude change case, the thrust climb mode is limited in order to give 1000 foot per minute, making this altitude change smoother and more comfortable for passengers. Speed considerations to climb. The manager selected, manage climb speed, computed by FMS, provides most, yeah, sure. Finally, a selected speed does not provide optimal climb profile, should only be used when operationally required. Example with ADC constraints or weather. Vertical performance predictions. Max recommend altitude and optimal altitude information for the cruise / altitude considerations. Like crew uses information to rapidly answer the HK climb the flight of yeah, and that's on the progress page, isn't it? We have no progress page. Recommend a max 430 and now max 340, optimum is 410. Climb panel of the from selective per page displays time and distance page for you. When switching the altimeter setting from QNH or QFE if available to standard to save the altitude that was graphically displayed. Able to switch to this is equal to the highest altitude along the flight plan on the vertical display range. This may result in the aircraft being below the displayed safe altitude. This functionality increases fuel awareness recalling the safe altitude. Yeah, lateral mode. Ah, finally. Last one, lateral mode. If the aircraft is following the programmed SID, the autopilot flight director should be in nav. If ATC vectors the aircraft, heading will be used until a timeline clearance is given to either resume the SID or track direct to a specific waypoint. In either case, the crew must ensure that the waypoints are properly sequenced. The crew should keep in mind that the use of heading mode, for example following ATC, will refer to climb to Omen climb and any. Yeah, we know that. Okay, finally we're done with the FCTM. Let's go over the takeoff procedures. For crosswind takeoff, no, it's not for us today. But we've already checked that. So setting for additional training. The callouts, let's have a look at the callouts. Cleared for takeoff, cleared for takeoff. Time set, time check. Man flags, 65, SRS runway, auto thrust is blue. Thrust set, checked. 100 knots, checked. V1, rotate. Positive climb, gear up, gear up. Autopilot 1 on, autopilot 2 on. And then we do not have the climb checklist, do we? No, we do not. 10,000, check. Transition, altimeter reset, standard. Let's actually go to flight level 70. Because then we can also do the transition. Perfect. And we don't have a checklist. Let's following takeoff is permitted. Takeoff announced. Thrust 25%. Apply 25% of thrust and all 4 engines with brakes set on. However, the flight crew can release the brakes to perform a rolling takeoff. What's our stopping margin? Oh, 746, so we can do it with the brakes released. But I won't, just to be on the safe side. If the crosswind is brakes released, we will go flex. Start chrono. Time set. Time check. Take off. Oh no. Wait, what? Okay, so we will we're cleared for takeoff. Okay. Release the brakes 25%, time set. Set the chrono, time check. Take off and then set flex or toga. Then go man flex 65, SRS runway, other thrust is blue. Thrust set, 3480 knots. Can the PFD and engine indications. At 100 knots. 100 knots and outs and 100 knots. Cross check. When 100 knots to P, pilot flying can decide to abort the takeoff depending on the circumstance. Above 100 knots, rejecting the takeoff is a more serious matter. Add V1 for additional information on the associated callouts. Sure. VR rotate. And that's VR, isn't it? Or rotate? No, it's rotate. Then positive climb. Does not yet VR initiate the rotation towards a pitch attitude of 12. If a tail strike occurs, the EGAN triggers the tail strike alert. For more information, refer to the procedure. At 30 feet, if nav is armed. The flight crew did not preset any nav on the gauges. If nav is not armed, runway track engage at 50 feet and is displayed. Positive climb. Then you go up, autopilot on, autopilot off. At the thrust reduction acceleration, correction at the thrust reduction altitude, you lever climb flash on the FMA. Thrust starts to climb, auto thrust automatically activates, auto thrust appears in white on the FMA, when the aircraft reaches 1500 feet right at thrust reduction altitude, whichever occurs first. The crystal steep page appears instead of the engine as C. More information in the FMA, display during it, sure. X1 and 2 if applicable on at acceleration altitude, we know. Above the acceleration altitude or when in climb phase. Following procedure ensures that the aircraft correctly accelerates towards the climb speed. Hold on, I just... Following procedure at f-speed, takeoffs and cover compass f-speed does not appear. At f-speed, flap 0 or flap 0 set. Exterior lights, set ground spoilers and the sign. Normal takeoff pattern. Normal takeoff pattern. Note, in the case of an immediate landing and if the pattern occurs below 1500 feet, press the recall push button on the ECAM CP during the downwind leg. MFD setting. Perf takeoff. V2 is 148 and flex temp 65. Thrust reduction and default is 1500 AGL. And minimum 400 feet AGL acceleration same. Performance climb only if climb speed is different from econ speed. Okay. So we don't have that, so we're on the takeoff page. FSCP setting, first cleared altitude flight level, which is flight level 60. Heading preset, we know we're using nav. First lever is flex or toga at 80 knots, thrust check before, or 80 knots thrust check. 100 knots, 100 knots checked. At VR, rotate to 12.5 degrees of pitch. We'll do 11.5 degrees. After liftoff, follow SRS. Then we will go V2 plus 10, 18 degrees max. So maximum of 18 degrees on the pitch. Wow, that's not a lot. Positive climb, gear up. And autopilot engaged if desired. Thrust lever is climbed when the thrust reduction altitude has been passed and after climb is slashing. At acceleration altitude, target speed, initial climb speed, and follow the flight directors. Flaps 1 if applicable, which is not today. We will retract to flap 1 during acceleration, and at S speed we will order flap 0. That's a normal takeoff pattern. Let's also go over the after takeoff procedure. APU. If the APU is used to supply the air conditioning during takeoff, APU bleed and off and APU master off. TCAS, if takeoff is performed with TA only, TA push button, TA RA. Anti-ice protection, the flight crew should set to on the engine anti-ice push button switch when icing conditions are expected with the TAT at or below 10 degrees Celsius. Which is not today. Sliding table released. After takeoff climb checklist down to the line. No, we don't have that. Let's go over it. Takeoff align with the runway. Check the runway heading and runway designator. Confirm takeoff reminder. HAA. What's that? It doesn't say. Perfect, take a reminder. Now it's time for takeoff. After obtaining takeoff clearance, repeat ATC clearance curve for takeoff, read back ATC curve for takeoff from the elapsed time. Time set, takeoff, then time check, start the chrono. Oh, I get it. Oh. It wants us to do the elapsed time. Time set, takeoff, time check, start the chrono at 25% of thrust. And then set flex or toga, man flex 65 or toga. SRS, runway or plank, auto thrust is blue, checked. Note, if the FO conduct takeoff after thrust set flex or toga, the captain's hand must be on the thrust levers until V1 and FO's hands must be removed from the thrust levers. Before passing 80 knots, thrust set and checked. If auto thrust has failed, revert to manual thrust control. Call set thrust. Thrust lever set to the thrust limit, thrust set. With a manual thrust control. Thrust engines. Let's control. Here we go. In manual mode, each engine is controlled by the position of the associated thrust lever. The flight crew controls the thrust by moving the thrust lever idle to toga detents. Each position of the thrust lever within the idle to toga detents range corresponds to a percentage of thrust. Okay. At 100 knots, checked V1, V1 at VR, rotate, when V is high is positive and the radial altimeter has increased, and also when the speed is increasing, or we're at V2 plus 10 and staying and not decelerating. Positive climb, gear up, lever climb flashing on the FMA, lever climb, thrust climb, auto thrust. Lever climb, auto thrust. Checked, time reset the chrono. Ah, it wants to time on the chrono in case of an engine out if we have to use toga thrust. At acceleration, altitude, climb or open climb, checked. Check target speed change from V2 plus 10 to the first climb speed, either pre-selected or managed. Managed speed, and in this case it will be like, I don't know, 205. At F speed, flap 1, speed check, flap 1. At S speed, flap 0, speed check, flap 0. Turn the exterior lights, runway turn off lights, and the nose lights to off. Landing line maybe left on, ground spoilers, lever disarm, and no checklist after takeoff. For the climb procedures, you know what? Well, actually, let's go over it. Climb, initial climb. The usual vertical mode is climb or open climb with managed speed active for additional training. We already checked that, right? Yeah. For additional training, number 140, we already checked 140, cruise flight level set as required, update the secret aircraft to schedule cruise flight level or above. It is not necessary to modify the cruise flight level as inserted. what, let's actually go heading and climb up to 100 knots. Or flight of 100 knots. Flight of 100. Yeah. So that's him. Alright, so let's go into heading at that moment. 10,000 feet, landing switch off, seatbelts as required, EVA's options. Required, incapable, view, planet flying, roadblocks early. It's clear. Next one to check 10,000 feet flow pattern. Transition out to barometrics and standard course check. Okay, we checked everything up to the climb procedure, so let's have a look at what he does.
And then wait for it to close. So we got land flex, SRS, auto thrust. Thrust is set. Is checked. V1. Rotates. So 3 degrees seconds, 12.5 degrees. Multiply, gear up, nav. So let's climb. Line. Take a snap back, just out. Let's continue up back to 8,000 feet. And now you see the SV is quite close to low speed, so it should auto retract. Yeah, there's the auto retract. And now this does climb like most, so keep it at something like 2,000 feet. If I leave it in open climb, it will just shoot up to something crazy. So that TCAS standby right now is just reaching us to let's fly heading 015. Reaching 040. So that TCAS standby, which is the same which is a few times. So that's 2 so 7 inch to Cool, now I'll show you quite another cool function. So let's continue to climb down to 12,000 feet. So if I expand to, let's say we'll go to I should be able to.
Okay, we won't have to do vertical speed 1000 feet per minute upon reaching cruising altitude. Okay, in that case, are we ready for our first ever departure in the A380? First real, well, this is still a training session, but the first loggable A380 departure. No tires below 590. Everything's fine. It's not about following the SID, it's about following the correct A380 procedures. So, tower speedbird 9865 super, we are ready for departure. Speedbird 9865 super, wind calm, clear for takeoff, runway 27 right. Clear for takeoff, runway 27 right, speedbird 9865 super. Okay, clear for takeoff, clear for takeoff. Set time. Perfect. Take off. Release the brakes. Time set. Take off. Man flag 65, SRS, runway, auto thrust is blue. Oh, enemy. Just set. 100 knots checked. V1, rotate. Positive climb, gear up, now. Okay, stop the clock. Okay, stop the chrono. And speed flap 0, speed check flap 0. Pilot 1 on. Pilot 1 is in command. Okay, so let's pass the sim. Let's see, did we do anything wrong? I think most things went right. I just want to see the callouts. Time set, take off. Time check. Flag 65, SRS runway, SRS blue. Gear up. I didn't say the second gear up. Lever climb. Lever climb, thrust, climb, and auto thrust. Checked, time reset. No more in climb. Checked. Manage speed 250. Check flap 0, that's all done. So, not perfect, but pretty alright. Alt star. Alt. Let's continue climbing up to flight level 100. Position altitude, set standard. It's not going to set, we should pull. Reset standards. Standard reset. Weird because we are. I don't think that's correct. And alt cruise. 1,000. Check. Alright, let's end it here. Let's call it a night because it's 12:36. I think this is a very good point to end it here and continue tomorrow. Okay, perfect.